Alright friends, in today's What the Math series, we are going to be looking at a very interesting TV show. Remember the show that I predicted Donald Trump's presidency? That's correct, I am talking about The Simpsons.
Number 1. Who could have predicted President Trump? While none of us could, The Simpsons somehow did. Back in 2000, an episode showed adult Lisa Simpson taking over the White House for none other than Donald Trump.
Oh, hi Bob, come on in.
Of course, 16 years later, this very unlikely individual would in fact become president. We now know that Lisa Simpson did not follow him into the White House, but it's still pretty baffling that they even thought of this.
In one of the episodes of Simpsons, Homer writes something on the blackboard, and it is something like this. Now, why is this all of a sudden so interesting, or why is it warranting the story? Well, let's get to that part. We actually recognize, right? We recognize this one. X squared plus y squared is equal to z squared. Well, this was written by Diophantus in his book called Arithmetica, and he challenged his readers to find the whole number of solutions to the above equation. Well, there are infinite solutions, right? Remember Pythagorean triplets? So, if this is 3, if this is 4, this will be 5. 3 squared plus 4 squared is equal to 5 squared. Well, one of the very simplest examples, right? Now, this is the Homer equation. Why is this so special? Well, this is so special because this whole thing defies something called Fermat's theorem. Now, what exactly is Fermat's theorem? This is basically actually called as Fermat's last theorem. So Fermat, PLD Fermat, he got bored of solving this puzzle in Diophantus puzzle of x squared plus y squared equals z squared. He wanted to up the ante. He wanted to now find x cubed plus y cubed equals z cubed. He tried to find answers for this. He could only come up with something like very trivial stuff like 0 cubed plus 7 cubed is equal to 7 cubed and so on and so forth. He did not really get an actual solution. Then he went on to raise the powers, right? He wanted to figure out x power 4 plus y power 4 equals z power 4. Is this possible? Then he started doing that to x power n plus y power n equals z power n provided n is greater than 2. He wanted to figure this very, very important thing. Then what happened? Well, our dearest Fermat, he just told something like this. In his copy of Diophantus' Arithmetica book in 1637, he kind of scribbled a note. He just told that, I have discovered a truly marvelous proof for which this margin is too narrow to contain. Ooh. Most frustrating notes in the history of mathematics, man. Because no one could prove this theorem. What he basically told us, there are no solutions which can actually satisfy x power n plus y power n equals z power n, provided n is greater than 2. So there is not a single equation that actually satisfies these conditions for n greater than 2. He just told that, and he just wrote that this margin is too thin. Well, till 1995, nobody could prove this theorem, and this became commonly known as Fermat's last theorem because it was the only one of Fermat's claims that remained unproven, well, till 1995. In 1995, Fermat's last theorem was proven by a Princeton University professor, Andrew Wiles, and the proof ran to about 130 pages. No kidding, right? To prove that this is not possible, it took 130 pages of proof. Fermat was pretty clear in that, right? So, if this is not possible, then how is this possible? Well, let's take our calculator. And I have typed in 3987 power 12 plus 4365 power 12. Let's see the answer. It comes to around something like this. It says 6.397 into 10 raised to 43. Alright, let's also check what is 4472 power 12. 32. Oops. Okay. Well, same thing. 6.397 into 10 power 43. This does match out, right? But if you actually calculate, really, this whole thing is actually, to be very honest, it is 4472 point. There are about 8 zeros. And then you get some numbers. 6, this whole power 12. Well, Fermat's last theorem still holds good for whole numbers and the 130-page proof as well, thankfully. Now, how did they get all these things? It's almost close. Nobody can figure out, but it got the whole world perplexed that, oh, somebody disproved a mathematical thing of Fermat, and that too in a TV show. Well, this whole math prank was played by David S. Cohen. Now, who's David S. Cohen, friends? Well, Cohen obviously knew Fermat's equation has no solutions, but this was his way to pay homage to one of the greatest mathematical minds, right? Fermat and also to Andrew Wiles. So what happened was, in order to find the pseudo kind of solution, he wrote, and David Cohen wrote a computer program that would scan values for variables like this, x power plus y power is equal to z power, and until it found a number that almost balanced. And like this, Simpsons has a lot of mathematical tidbits in the episodes. Hopefully in the next What the Math series, I'll cover some of them. And who David S. Cohen is? He was one of the mathematical genius writers who joined Simpsons' writing team in the mid-90s, friends. Actually, he went on to study physics at Harvard University, but then his passion of writing took over and then he became a writer for the show. There are 3 equations that he kind of writes on the blackboard. Homer writes. The first equation is about Higgs boson's mass. And that was because that work is largely based on David's friend, again called David, but this is David's Skiminovich, who kind of had his work on Higgs boson and how to compute mass of Higgs boson. So he took that and then he found out this Homer's last theorem. And there were a couple of lines as well, as you see in that image, that it actually concerns about the density of the universe and an area of math called as topology. So this is how perplexing it is, friends. So don't worry, this is still not possible, but you can still write a code. With all the AI today, maybe we can write some more fascinating tricks and insert it in a lot of TV series. Hope you liked it. If you do, give me a like, share, and subscribe to the YouTube channel, friends. I'll come with a lot more fascinating math stories. Thank you.